Okay, here we are on the third section. It says definition of a statistical question. Okay, so here it is. A statistical question. Any question whose answer could involve working with more than one data value. All right, so which means if you have a statistical question, it has to have more than one answer to it. So if someone asked who was the first president of the United States, no matter how many people you ask, that's not going to be a statistical question, okay, because it's only one answer. But if you ask who was your favorite president in history, then you're going to have all kinds of answers, and that would be considered statistical. So let's look at each one of these down below and see which one is which. So it says Tony asked one of his coworkers, "What is the number of computers that your family owns?" Well, he just asked one person, so it's going to be one answer, so that's not statistical. Next one. Abdul asked the students in his class, "What was the number of movies that you watched last month?" So he asked multiple people, and each one of them is not going to watch the same number of movies, so you're going to have a variance of answers. So with that being the case, that would be statistical. Okay, so you're going to have a variance of answers, definitely more than just one. Next one, Susan asked 30 people in her city, "How many songs did you download last week?" So is every single person that she talks to going to download the same number of songs? Well, the answer is no. So once again, you're going to have a variance of answers. So that, yes, that would be a statistical question. D, Nicole asked several people at her church, "How many minutes did you spend on the internet last night?" So is everybody going to spend the exact same amount of time on the internet? So there's only one answer to that? No, once again, that's going to be multiple answers. So that will have variance. So yes, that is a statistical question. And then E, Ravi's teacher asked him, "How many times did you shop at a mall last month?" So Ravi asked one person a question and he's going to give his answer. So that's only going to be one answer. Okay? He's not going to have multiple answers about how many times did you shop at the mall last month. So whatever answer that is, that's going to be it. So that is a non-statistical question. All right, number 15. Teresa has D decks of cards. We don't know how many decks of cards. It could be one, it could be two, it could be 100 decks of cards. It says each deck has 52 cards in it. Okay, well, that makes sense. Using D, write an expression for the total number of cards Teresa has. Okay, well, we don't know exactly how many cards she has, but we know that every deck has 52 cards. And so once we know the number of decks of cards, then we just have to multiply that by 52. So once again, just like we kind of said on an earlier problem, you can just put 52D, because that means 52 cards times D. So if it's one deck of cards, 52 times 1. If it's two, 52 times 2, and so on and so forth, and that would be the expression, okay? So once again, it's an expression because there is no equal sign. But also remember, you can actually make this 52 times D by putting the dot right there. Whoops, let me make sure that's a D. Okay, or you can put 52 with the normal time sign that you're used to, but you're kind of going away from that because we're going into algebra, so the dot is kind of replacing the time sign. Or you can put parentheses around the 52 and put a D right beside it. And you can do something like that. Put the parentheses around that. Okay, any of those, once again, would be a good answer to this problem. All right, number 16, simple instruction is to factor. Okay, so factoring is basically the opposite of distributive property, where you take something outside of the parentheses and multiply by everything inside. You basically look at these numbers and think, what number can you divide into both 6 and 4? Well, they're both even numbers, so you can definitely divide a 2 into both of them. 2 goes into 6 3 times, and 2 goes into 4 twice. So if you're factoring this one, you're basically taking the 2 out, and you have a 3 plus 2w. Okay, and the reason why you know that that's something that would actually work is that 2 times 3, again, is 6. And then 2 times 2 is 4. So again, you're just kind of going back and forth between distributive property, where you're taking the number on the outside and distributing it to everything on the inside, in comparison to factoring, where we started with the 6 plus 4w and took the 2 out of it, okay, and then found out that 3 plus 2w would be the factor of that one. So if you're factoring it, you find a number that goes into both of those and put it outside the parentheses, and then divide everything by whatever that factor is, and that'll give you what's inside the parentheses. All right, number 17, it says the salaries of the employees at 4 companies are summarized below. All right, so here's the deal. We have a situation where they are showing us the mean salaries, which means on average, what does the person make in this company? Okay, so on average, so there's people who make a lot of money, there's people who make a little bit of money, but the mean salary is the average of those salaries. And then they're also giving us the range. So from the highest paid person to the lowest paid person, the distance between those two is $50,000, okay, for company A. The highest paid person to the lowest paid person for company B is 48,000, and the same thing. Highest paid to lowest paid, highest paid to lowest paid. Those are the ranges. So the range is always the highest minus the lowest. Okay, so that's the distance between those two. All right, so then based on the information above, which company's salaries are the most spread out? Okay, so which one is the most spread out, which means we're probably going to be looking at the range, right? The most spread out from the highest paid to the lowest paid. Well, which one has the biggest distance? Well, the one that has the largest distance from one person, from the highest paid to the lowest paid, would be company C. So basically, company C kind of has the largest range, okay, because the salaries are the most spread out. Okay, let's look at the next one. It says, based on the information above, which company has the higher salaries overall? Okay, so what you're going to do is you're going to look at these and say, well, on average, which company pays the most? Okay, on average. So some people are paid more, some people pay less. Okay, on average, who's paid the most? Okay, and of course that would be company B. So on average, the person in company B gets paid better than any of the other companies. So that would be the answer to that one. So that's how you do number 17. All right, number 18, we are just being asked to plot. We're going to plot the negative 11. We're going to plot an 8. We're going to plot a negative 2. All right, well, if you're going to do a negative 11, you start here at 0, and you go to the left. And you're going to go to where there's a negative 11, which would be 1 further than negative 10. So there you go. That one's going to be negative 11. Then we have an 8. I can't remember if I said a positive 8 or negative 8. So the 8 is going to start here at the 0 again, but it's a positive, so it's going to go to the right, and it's going to go all the way up to 5, then 6, 7, 8. Okay, so then this here is going to be where we plot the number 8. I guess I can just put this negative 11 here. And then the last one is negative 2. So once again, starting here at 0, you're going to go to the left. We don't want to get to negative 5. That's too far. So negative 1, negative 2, that would be right there. So we'll just plot that one, negative 2. That's all you have to do if you're plotting on a number line. All right, so on this next one, it says graph the inequality below. So graph the inequality below on the number line. So B is our unknown number. This sign, the smaller sign, is always pointing to the less sign, lesser than. So B is going to have to be a number lower than negative 7. So basically, we want to just start right here at negative 7 and circle it. Okay, that's kind of a circle. And then we want to go below -7. Well, if you look at the number line, these numbers are going to be going towards a positive direction, which means these are going to be greater numbers. They're going to be larger than -7. So we're actually going to go the other direction down this way and plot it like that. That's it. Now, the other thing is, it didn't do this, but if you see b is less than or equal to, if it has a line like that, you would actually color in the circle because that means b is less than or equal to -7. Okay, but in this situation, you don't want to do that. You want to leave it like this because it does not say b is less than or equal to -7. You're not going to include the -7 in this situation. There's your answer for number 19. All right, number 20, solve for W. All that means is you need to get this W by itself. All right, well, all you have to do to solve for this one is you just do the opposite operation of whatever is happening. So if you have a 7 and a W right next to each other, that means that's multiplication. Well, the opposite of multiplication is division, just like the opposite of addition is subtraction and vice versa. So you're going to divide both sides by 7. If you do that, 7 goes into 7 one time, so we just have one W left. So we could put a 1 in front of it, but that's unnecessary. We know that that is just one W. And then at that point, if you put 17.5 divided by 7, you're going to end up with 2.5. So W equals 2.5. And you can check that. Just do 7 times 2.5 and see if you get 17.5, and you will. Okay, so that's how you solve for W in this situation.